manufacture of a product.
We live in an era where digital technology is at the forefront for broadcast television, video production and the motion picture industry. One of the many companies at the heart of this digital technology is Quantel. They've used this as a creative tool for over 30 years and are using their vast experience to create tools for the new digital age, covering everything from terrestrial and multi-channel television to broadband internet, DVD and D-cinema.
The key to having ideas really is to have lots of information. What our idea is of a product will change as our customers give us feedback. And we make a thing very iteratively. We'll have an idea, we'll try and prototype it, and then many times a week and a month and a year, we'll improve on it, we'll judge it, get feedback on it. The complexity that we have to manage to make the size of products that we do is far too big for one person to be able to keep in their head all at one time. We make building blocks, many different little components, software and hardware components that we can glue together in lots of different ways. And if we didn't have computer tools to help us manage all that data, we just couldn't build what we build.
After we've received the schematic information from the R&D engineer, the first thing to do is to extract a bare printed circuit board from the vast library we've built up over the last 30 years. We then go on to place each and every one component onto that board. This particular card has 4,675 components, and each and every one needs to be individually placed. We can now show the interconnects as guides. Again, on this card there are 26,000 of these interconnects which need to be automatically or manually tracked. A board of this complexity would take at least 6 weeks to design at Quantel. By having all of Quantel's designs on computer means these actual designs can be changed within days if need be.
So what happens when the design is complete?
Once the drawing office have released the design for us to manufacture, the same data that was produced in the CAD drawings is used to drive our machinery here and to send to our suppliers to actually provide what we need to make the final objects. We have three significant areas of manufacture. Automated assembly, where we actually use the machines to help us. We also have hand assembly, where skilled operators are working to engineer in drawings to put minute components down on PCB assemblies to effect the changes and modifications from R&D. Our final assembly allows us to put together for our customers exactly what they need in the format and configuration that they require for their final product. Quality is an integral part of every stage of our manufacturing process. We now have an X-ray machine which actually verifies each and every solder joint on that board, whether it can be seen or not. Some of these devices are checked at up to 60 solder joints per second. Having R&D engineering and manufacturing on site enables us to quickly adapt to our customers' needs.
24-hour helpline is available via phone, fax, web chat or email and provides the reassurance that a skilled engineer will be on hand around the clock to identify and solve a problem quickly. Most faults are remedied over the phone and spare parts are on hand in warehouses all over the world. We all take for granted how much work goes on behind the scenes to deliver the news, and more so when the journalist on the road these days is also in charge of putting together their story before it goes live to air. So what equipment is there to make life easier for the busy journalist?
Newsbox is a system designed for broadcasters to produce news very fast. If a news story breaks, they need to be sure that they can have that ahead of their competitors, and the simplicity of Newsbox is what allows them to do that. You don't need to be technical to learn how to drive Newsbox. With about 5 minutes training, we can take a journalist who hasn't sat down at the system before and teach them how to select a shot, publish it and get it onto air as a headline.
The equipment we're using here enables us to maintain the highest possible quality from the capture of the images through the post-production editing, through to transmission. We're able to manipulate and move pictures around as data, whereas in the past we used to have to edit by copying from one tape to another, and obviously if we want to make changes we'd have to copy off again and again and again, whereas with modern computer-based systems all we're doing is moving data around, and we do not suffer quality losses due to making copies. If we didn't have this technology, if we were using older film-based or tape-based technology, the working schedules and the working day would be incredibly long.
Colour grading was traditionally done at the film laboratory. It was a slow process where shots could be individually colour matched to each other. The advantage of doing it digitally in the IQ means that we can go to any part of the film and adjust the colours to how the director wants them. We can go through and match shots, or we can give the piece a specific look. Using this type of technology allows us to create very high quality masters of the piece that we've been working on. The image quality is as good as when the director was looking at it in the session.
Technology has allowed the broadcasting industry to achieve things considered almost impossible or prohibitively expensive 30 years ago. Quantel realises that to maintain its position in the industry, it needs to adapt to using new technology.
In your exam,